All right, on this particular problem, we have people on social media starts out with 3 million, so we put it right here in 2020. So that really means million. I'm not going to write million, but I'll just leave it a 3. And then it triples every year. So if this was 3 million, 3 tripled. So the next year will be 9 million. Triple that is 27. Triple that is 81. And triple that is 243 million. Now, dividing it going the other way, 3 divided by, so that's going to be 1 million. Now, you could have just put 1/3. 1 divided by 3 would have been 1/3 of a million. Some people did that. Some people went right to their calculator and rounded it. So that's okay too. So if you just put something like 0.3, that's fine. And then if we take that and divide it again, oops. So now I'm going to divide it again. So to 0.1, so 0.1 million. And if we divide that again, 0.04. Now these are a million. So really 0.3 times a million, so that's 300. Now remember, it was 0.3333, but I'd be okay if you rounded. That would have made that 300,000. This would have been 100,000. And then 0.04 times a million is 40,000. And if you're not sure, you can always just type that in. You have a calculator right there. You can just type it in, 0.04 times 1 million. 1, 2, 3, 4, 5, 6. See, it's 40,000. Okay, so we got the table filled in. How did you go forward? Well, just like in our examples we did in class, we did 4 of these. It's the same answer. We multiplied by 3 going up, and we divided by 3 going down. So what was our equation? So the equation is whatever's in the 0 spot times the base. So right here is the 0 spot. It's 1 million. So 1 times 3 to the x power. That was all we had to do. Some people put 1 million times 3 to the x power. That's also fine. You could have done it either way. I'll just tell you this number later on is going to be too big for your calculator. That's why they put it in like that. Okay, so assume the total number of users continues to triple after 2024. Determine the number of users in 2027. Okay, well let's do that. We just got to keep going to 2027. So 2025, 2026, 2027. Let's crank it up there. Let's just keep multiplying by 3. So, where were we at? 243 times 3. So that was 20, that was this one, 7,329. Oops, I didn't type that in right. That can't be right. 243 times 3, 729. Times 3 again. Turn over there. 2,187. And then the one we're looking for, times 3 again, 6,561. Now remember, that's in millions. So we had in 2027, there would have been 6,561 million. 1, 2, 3, 4, 5, 6. So that's 6 billion people, 6.5 billion people. So that's how many. Now, the rest of it says, given the world population in 2016 was approximately 7 billion, is this assumption reasonable? Now, the question is not asking, is there the same amount of people? Did we get the same amount of people that there's going to be? The question is asking, is this a reasonable number of of people using social media. This means how many people are in social media. Well, if the world population is not tripling every year, the world population is growing, but it's certainly not tripling. So in 2027, there will be around 7 billion people, maybe a little bit more. So if there's 6.5, is it reasonable that our model is predicting 6.5 billion people being on social media? Okay, the answer to that is no. This is almost everybody in the world. 7 billion people versus 6.5 billion on social media. You would be saying that everyone in the world has a computer, everyone in the world is on Facebook, everyone in the world has a phone. That's simply not true. There's at least 2 or 3 billion people that do not have access to social media. So that's what you needed to write. No, this is too many people. No, it's very unlikely everyone in the world will have a phone. Has a phone or will be on social media, something like that. Okay, let's take a look at question number 2. Jill writes this and the teacher marks it wrong. Explains Jill's error using both words and pictures. I was trying to give you a hint on how to deal with this, and pictures. Okay, here's a picture of this, 2 times 2 times 2. Here's a picture of this, 2 times 2 times 2. That's a grand total of 6 2s. It has nothing to do with a 4. So I just didn't want to rule, and I just didn't want to know what the answer was. Some people said 2 to the third times 2 to the third equals 2 to the 6th. Okay, that's not explaining anything. That's just showing me the rule. The explanation is this means a bunch of 2s, this means a bunch of 2s. The answer is a bunch of 2s. So there's the picture, and explain Jill's error. The problem is asking to rewrite a bunch of 2s, not a bunch of 4s. The problem has nothing to do with 4s. It's 6 2s. Something like that. Okay, use the definition of exponential notation to determine why this is true. Okay, we needed something like this. Okay, 4 to the third. But 4 could be broken down to 2 times 2. See, this is exponential notation. See, that's another way to say 4 to the third. Well, 2 times 2 to the third, now that third can go in there. So that's the same thing as 2 to the third times 2 to the third, or 2 to the 6th. So we can replace that with 2 to the 6th, which now means we have 2 to the third times 2 to the 6th equals 2 to the 9, and that is true. That's what we were looking for. Explain something like that. 2 to the 4 could be replaced with 2 to the 6th. Of course, I would need words for you to say all of that. 2 to the 4th. 4 to the third can be replaced with 2 to the 6th, making 9 total 2s as stated. Something like that. Okay, we're looking for a picture. Pictures are your friends. Challenges you to prove it. Okay, this 7 to the 4 or 7 to the 9 means downstairs. So that means what we really have then is 7 to the 5 over 7 to the 9, and now just saying and use the rule is not really a proof. That means 7, 7, 7, 7, 7, and this one means 7, 7, 7, 7, 7, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. those reduce, those reduce, those reduce, those reduce, those reduce. So we have 1 over 7 to the 4th, which is the same as 7 to the negative 4. Something like that. Okay, 3 proofs. This was probably the proof that most people showed. So here's maybe proof number 1. How about pick any number? How about like 5 to the 3rd over 5 to the 3rd? Okay, that means 5 times 5 times 5 over 5 times 5 times 5. They all reduce away, which leaves 1 over 1, so it's 1. But then you have to compare that to the rule. The rule then says it's 5 to the 3 minus 3, which is 5 to the 0, and those two things are the same. That was one of the proofs. You only had to do one of these. That's the one most people chose that got it right. Another one that people chose that got it right was by pattern. If we have 5 to the 3rd, that's 125. If we have 5 to the 2nd, that's 25. If we have 5 to the 1st, that's 5. And if we have 5 to the 0, okay, look at the pattern. That's divide by 5. That's divide by 5. This one will be divide by 5, which makes that a 1. So you could have shown it by pattern. And then the third one was a word proof. 5 to the 0. 0 means there are 0 5s. Okay, well, when we're talking about a fraction and there are 0 5s, if there are 0 5s, there's a 1 left. There you go, 1 over 1. That's what 0 5s means. There's 0 5s there.